welcome to TechEd session DT200. It's about table management. So what can you do to reduce your in-memory data footprint by usage of SAP HANA technologies and how this can be applied to S/4HANA systems. My name is Claudia Semmler. I'm working in the S/4HANA product management team, and I will guide you through. We are a bit in a rush, so don't worry if it goes fast. I hope maybe you can later on stop the video and reread the slides, but I wanted to get as much through as possible. So let's start with native storage extension. What is about? First, some context. So it's an technology used for data tiering. So you see here on the left side, HANA memory is the hot tier, but we all realized that it's not necessarily required to have all possible data always in memory. So there should be a bit less expensive storage options within HANA, which is disk, and that's the so-called warm store. And one technology used to provide a warm store is native storage extension. Then in addition, there's cold store. This is data stored outside HANA database, usually accessed pretty slow. So what is native storage extension? On the top, you can see how HANA usually works. It's basically whatever column is accessed, it's loaded fully and completely to the main memory. And native storage extension introduces not only this column loadable concept that you are already used to, but introduces a page loadable concept, which means not the full column is loaded, but only selected pages. They are loaded to a buffer cache and accessed from there. And if you say, well, that sounds familiar to me, wait a minute. Yes, indeed, this is basically the idea that you are used to know from other disk-based databases that are around for quite some years. And name native storage extension is because this capability is now really natively built into the SAP HANA database kernel. So the advantage is that you can move out data that you may not access that frequently. And the question is how you do this. You can do this either on table level or column level or partition level. And so that's the three different concepts. And how you would do this, you would enter a statement on HANA database level, alter table, and set the so-called load unit to page loadable. The load unit is a new characteristic of a table and can either be page loadable, which means only pages are loaded, majority of the tables on disk, or can be column loadable, which is just normal HANA, basically operation. The full column is always in memory. Table level is the easiest thing you would decide. So it is also the most predictable in terms of performance implications, because it's pretty obvious in case we go away from that idea, always is everything in memory, there will be a performance downturn because there may be disk I/O that have to be considered. So tables have to be chosen wisely. Column level, this is a very good option in case there are individual columns that consume most of the space of a table. Then you just lay off those individual columns to the disk, keep the rest, mainly primary key and whatever you need else for searching in the main memory, and then get going and have some in-memory gain and still only little performance impact. Partition level sounds tempting because you say, well, anyway, I only work on current fiscal year plus previous year. Why don't put the older partitions to NSE? Is basically a good idea. If it really works out, strongly depends on the kind of where clauses you have and if that exclusion of disk-based partitions can really be handled well. And that all depends on the where clause and your partition criteria. But thankfully, you're not alone in this decision. There's a tool which is NSE Advisor, which helps you to take good decisions. And this advisor just collects data, statistics, and provides guidance on this. And how this works and how this looks like we want to have a look now in the demo.
Let's have a look on how you could work with the NSE Advisor. So first of all, you have to activate the statistics collection, which you could do, for example, here in the SQL editor in the DBA cockpit with the following statement. Auto system, auto configuration, index server ini system, set CS access statistics, collection enabled, true with the reconfigure. So you would run this statistics collection active for a representative workload for a few hours or 1 to 2 days. So from experience, we have seen that just even a few hours of representative workload provide good results. After you're done with the statistics collection, you would switch off the collection again. Same statement, but with false instead of true. In case you are wondering, is it active or not, you may check the ini file. So go here, ini files, index server ini, scroll down, CSS access statistics. And here you see, in my case, I already disabled the statistics collections. So now we are ready to check the results. So how to see the results? Again, here that's one way to do it. So you could do a select on the system view for the NSE Advisor. And what you get is a list of tables and a recommendation on where those tables should be put based on the load unit. So load unit page loadable means NSE, so mainly disk. Or you see here also load unit column, in case you already had put something on NSE, but the advisor thinks, well, this is a pretty busy table, pretty heavy read workload on it, and then you may get the advice to put it back to column store, so to column-based settings, so that the table is always in memory, the full table. So here you can see on the granularity column, there are two options you may get as recommendation. The one is table, which means the full table is a good candidate to be put on NSE. Here, the top two ones, for example, these are the hold the information about ABAP transport. Read once in case the transport is imported successfully, or twice in case you have to redo it. So rarely read can get quite big, those tables. So these are, let's say, pretty obvious candidates for page loadable. And further down, you see here there are other objects, other tables where not the full tables are recommended to be stored on disk mainly, but only individual columns of those tables. So here, as an example, you see two tables with a column name which is called class D. That's a cluster column which usually holds binary content of a table like PDF document files. That's here for document management. So that's usually quite a large column with significant size, but not used in any select queries. So only accessed on demand in case you really want to see this individual document. And further down, you see an example where multiple columns of a table, here in that example CKIS, are recommended to be stored on NSE. And then here we have one example, tables USB for controlling field HRKFT, which with a significant size. So you may think, oh, why is it especially that column that I should put on NSE? And in case you want to know more about this, you may have a look into the sizes that the individual columns take. So you could do a query on CS all columns view for that table you're interested in. And here in that example, you see the sizes and memory sizes by individual column. And what you can see here is that this HRKFT column has quite a significant size. So that means in case you put just this single column on disk, you'll already gain a good effect on your memory footprint, but not necessarily have an effect on all other queries that may not include that column. So this is a kind of a safe side option. Okay, let's get back to the presentation.
All right, after having seen how this looks, the NSE Advisor looks on the system, I want to talk a bit about how this NSE can be really adopted and used in an S/4HANA system. So current use cases are data aging, and there is a banking solution called Financial Product Subledger that explicitly count on NSE. And we had a bit of hesitance of promoting NSE on a broader scale, because the data dictionary so far was unaware of the page loadable setting. That means the data dictionary is defined to be the master of the database objects. And the idea was not really mess around on HANA level with things that data dictionary is not aware, especially as this may cause risks in table conversions. Thankfully, this situation has been overcome. So with the next S/4HANA release 2020, there will be a page load or load unit setting in the data dictionary. And with a node listed here, you will be safe that in case of table conversions, your load unit settings that you did on HANA level will be kept and not reversed. We have some productive usage at some customers, and also SAP internally, our production systems for some tables and selected columns run on NSE, and that proved out to be a great success. Future adoption, well, technical tables, iDocs, application logs, so whatever is big is mainly inserted and not accessed that often, and not accessed for complex analytical queries. Why we think it's a good idea? We see benefits. The implementation is much more simple compared to data aging and data archiving, because the visibility of the data doesn't change. It's still visible, but it's maybe slower. You can do reverse it. So in case you found out, oh, that causes side effects I didn't intend to have, or I don't accept, then just alter table, column loadable, and you're back in the memory game. You have to consider some monitoring aspects. That means the buffer cache that will then be set up has to be monitored at least in the first few months carefully. As said, constraints, choose the scenario wisely, and don't expect miracles. Probably ACDoc-A, which is basically the bottom and the core of an S/4HANA system, is probably not a good candidate. So another option, inverted individual indexes. So a primary key is usually a concatenated key, which means all columns included in the primary key are combined into one long field. And that can be pretty much causing memory consumption. So an alternative to this is the so-called inverted individual indexes. They can bring down the size of the primary key significantly. They partly even have positive effects, not only on the memory, but also on index creation and on bulk inserts, but there are also performance downturns. So idea, don't use inverted individual indexes on heavily used, highly performance critical tables. These are examples that we quite often see. So CD-POS, change document line items. What you see here is a sizing report. And you see that the primary key itself consumed 1.3 terabyte, which is more than half of the total table, including indexes consumed, which is 2.2 terabyte. CD-POS, anyway, not a heavily accessed table. Change documents are accessed individually on request. Basically no analytics on this. Same is true for the next table, like EDID4, which is an IDOC content table. Here also you see the primary key alone makes up 1/3 of the total table size. Other good candidates that we see for applying this index concept is the SARIX table. These are the archive information structure tables. Again, not accessed that frequently. And we have a customer that only applied inverted individual indexes on the SARIX tables and gained 670 gig of memory back. And that's a great success. Here, an example on, again, on CD-POS, success example. CD-POS primary key went down from close to 1 terabyte to 260 gig. Savings were about 700 gig. The magic thing about this operation was it took only 2 minutes, but be careful, reversing this, which is again possible, takes significant more time because that concatenated normal primary key index is big, has to be calculated, has to be put to the database. So that takes time. Performance impact can be noticeable, but in that case that I'm reporting here, was definitely acceptable. So in case you're interested, you may think, okay, which are good tables? Like with NSE, what are the tables I want to go for this? Here you can see some details. There's mini checks that you may know that show you which are the large primary keys. The middle part here shows you which are large primary keys and where you would see some benefits by applying inverted individual indexes, because the benefit strongly depends on which data is included in the index, how many index fields there are, what's the index portion compared to the total table. So there, the middle part helps you with. And when it comes to the performance impacts, the last statement can help, and it gives you an idea. Most interesting of this is here the line with a 21 to 1000, sometimes significant. So it's hard to guess automatically. So here, apply it on your QA system and test carefully. That's the advice we can give. All right, that was quite a rush, but don't worry. There's sufficient documentation, either in the norm documentation or in an SAP notes. There's also a webcast on data tiering, which I can really recommend. So in case you have the time, enjoy this, and enjoy also the rest of your participation at the TechEd, other sessions you may want to look into. And I want to say thank you for your attendance, and I hope you got something out of it, and hope to see you next time. Bye.